Hello viewers, in this video I will discuss on the topic dimensions. So what is a dimension? Any physical quantity expressed in this bracket will give the dimension of the physical quantity. Okay, so any physical quantity when you write in this bracket form, that will give the dimension of the physical quantity. Okay, so already we have discussed what are the two types of physical quantity. One is fundamental quantity, another one is derived quantity. First, we will see the dimensions of the fundamental quantities. So, what are the fundamental quantities? Let's see. So, you know that the physical quantity is divided into two. One is fundamental quantities. So, we have 7 fundamental quantities. We have length, mass, time, temperature, current, luminous, intensity, and amount of substance. These are the 7 fundamental quantities, and now I'm going to write the dimension of these fundamental quantities. So the dimension of length is capital L. This is the dimension of length. Not only for length, the terms related to length like breadth, height, distance, all these things will be represented in the dimension capital L. Next we have mass as capital M. So capital M is the dimension of mass. Similarly time, capital T is the dimension of time. Then for temperature we have capital K. For current we have capital A. Luminous intensity we have CD, and amount of substance we have mole. So these are the dimensions of the fundamental quantities. Okay, so these are the dimensions given for the fundamental quantities. Next we have to find the dimensions of the derived quantities. For that we are going to have a term called as dimensional formula. So dimensional formula. So what is this dimension formula? It is an expression. An expression which gives the dimension of the derived quantity. An expression which gives the dimension of the derived quantity. So let's see with the examples. First I will take the area, a derived quantity. So before going to write the dimension, first of we have to write the formula for the given derived quantity. So what is the formula for area? You know that length into breadth. This is the formula for area. So now I'm going to write the dimension of this derived quantity. So L, you know that it has dimension capital L. Next, you know that breadth also has a dimension capital L. So capital L. So we have L. So the dimension is capital L square. So this is the dimension of this derived quantity area. Similarly, we have volume. So what is the formula of volume? L into B into H. So here we have three quantities, length, breadth, height, all are considered as length only. So the dimension of these three terms, capital L, capital L, capital L. So totally we can write it as capital LQ. So this is the dimension of the volume. Similarly, another quantity, we can take it as velocity. So what is the formula for velocity? Displacement by time. Displacement by time. So displacement is nothing but the distance. Distance is nothing but a length. So the dimension of displacement is also capital L. By what is time? So capital T. So now take this T to the numerator. So here we can write it as Lt power minus 1. So we don't have any common power. So only have written t power minus 1 inside. Okay, so Lt power minus 1 for the power, for L the power is 1, for T the power is minus 1. This is the dimension of velocity. Similarly, acceleration. What is the formula for acceleration? Here it is velocity by time. So it can be written as, so you know the velocity dimension already, it is Lt power minus 1 divided by T. So it can be written as, so take this T to the numerator, again it can be written as Lt power minus 2, because this T when goes up, it again T power minus 1, so T minus 1 minus 1, it will become as T power minus 2. Okay, similarly, another derived quantity we can write force, mass into acceleration. Okay, so what is the dimension of mass? It is m. So capital M. So we have found the derived quantity, sorry, the dimension of acceleration, Lt power minus 2. So totally it could be written as mLt power minus 2. So this is the dimension of force, mLt power minus 2. Okay, so like this way you can write the dimension of various derived quantities. Okay, similarly another one I'm writing as density. So what is the formula for density? Mass by volume, mass by volume. So you know the dimension of mass, capital M, by volume you know the dimension, L cube. So it could be written as ml minus 3. So this is the dimension of density. So like this you could also write the dimension of the remaining derived quantities like power, energy, surface tension, stress. So we have many derived quantities that could be written by substituting the fundamental quantity dimension, and you can easily substitute in the formula and find the dimensions of the remaining quantities. So next we have dimension equation. We have dimensional equation. So what is this dimensional equation? The equation of the form. An equation okay, written in this form. Written in this form. For example, now I am going to write the dimension equation of velocity. So see that in the left hand side I am writing like this. In the right hand side I am writing the dimension of the derived quantity. So Lt power minus 1. So this is the dimensional equations. Writing the derived quantity with dimension like this in this form we call it as dimensional equation. Similarly, another one we can write force F is equal to, what is the dimension? It is written as mLt power minus 2. So this is the dimensional equation of the force. Okay, so this is the form of writing the dimensional equation. So now what is the use of this dimension? It is used to verify whether the given formula is right or wrong. We have F is equal to ma, we have the formula V is equal to U plus AT. So whether this formula is right or wrong, that is verified only by the use of this dimension. By applying dimensions, we can see whether the formula is right or wrong. So that is the main purpose of this dimension. Any formula could be created by checking the dimensions of the used terms. Okay, so if you are using many terms, derived quantities, we have to know the dimensions, we have to apply and then check whether the formula is right or wrong. Okay, so that is the main use of dimensions, and this is the overview of the dimensions. So in next video we will see how we could verify the formula by the principle of homogeneity of equation in the next video. Okay, thank you.